Now, so look at simplifying algebraic expression. And then the first simplification of algebraic expression we're looking at is collecting like terms. Now, when you are asked to simplify an expression, what you are asked to do is to express that expression in the simplest form. Now, you can't solve an algebraic expression because when you are asked to solve, it means that you are asked to find the solution. That is, you are asked to find the unknown. And remember that the unknown in mathematics is the variable, which is the English alphabet. And then you can only find the unknown if the equal to symbol is introduced. And once the equal to symbol is introduced, it makes it now an algebraic equation. It's no longer an expression, because the difference between an expression and an equation is the equal to symbol. So if I have 3x plus 5, for example, this is an expression. But when I introduce the equal to symbol to have, say, equal to 4, for example, this is no longer an expression. This becomes an algebraic equation. Why? Because the equal to symbol had been introduced. And what does this equal to symbol connote? It now connotes that we now have the left hand side, which is now the same as the right hand side, right? So it is at this point that we can now solve to find the unknown, to find the value of the unknown, which is x. However, if it is an expression, which is 3x plus 5, right, you can't find the value of the unknown as an expression. What you can do is to express that algebraic expression into its simplest form, and that's why it is simplified. So you can only simplify an algebraic expression, whereas you can solve an algebraic equation or any form of equation, right? And what makes an equation is the equal to symbol. So for every form of mathematics that you see the equal to symbol, then it means that mathematics is an equation. It could be called any name. As long as the equal to symbol is there, then it is what? An equation. However, the absence of the equal to symbol makes it just an expression. Now we want to simplify algebraic expression, and the first form of simplification is to collect like terms. Of course, we already know what a term is, right? A term could be a single number, that is a constant. A term could also be a single variable, right? And could also be the combination of a variable and a constant. So if I have a single number, say 3, for example, 3 is a term, right? If I have a single variable, say x, for example, it is also a term. A term could also be the combination of both of them in multiplication, 3x. So if I have 3 times x, for example, it gives me 3x. So the combination of both of them is also a term. Now, if I have 2 or more terms that are of the same variable, then we say they are like terms, right? And then when we have 2 or more variables, 2 or more terms with different variables, then we say they are unlike terms. Now, in adding or subtracting algebraic expressions, you can only add or subtract expressions with the same variable. Now, expressions with different variables cannot be added together. So for example, if I have 3x plus 4y, for example, this cannot be added together. It cannot be simplified. The result will still remain 3x plus 4y. And why is that? It's because both terms have different variable. Of course, you know, this is one term, this is one term. The first term has x as its variable, the second term has y as its variable. So for us to be able to add two terms that are two terms together, both of them must have the same variable. It could even be more than 2, it could be 3, it could be 4, however, whatever number it is, for us to be able to add or subtract multiple terms, it means that they have to have the same variable. So if you are given an expression for us like this, for example, say 3x plus 4y minus 2x plus 5x plus 4y minus 3y, for example, right? First, you will note that these are all algebraic expressions. This is an algebraic expression that contains how many terms? 1, 2, 3, 4, 5, 6. So it contains 6 terms. Now we can only go ahead to simplify this expression by collecting like terms, because you cannot add or subtract terms that are not of the same variables. So the first thing to do is to collect like terms. Now, in collecting like terms, you lift both the variable and both the term and its operator. For example, so we have 3x now. I need to bring 2x to meet with 3x so that I can now be able to add or subtract them together. Now, if you just bring 2x alone and just add plus 2x, you'll be making a mistake, because the operator in front of 2x is minus. So it means that when I'm lifting minus to come meet 3x, I lift it also with the operator, which is the sign. So I have minus 2x, and then I have plus 5x, because plus is the sign with it. Then I now bring together the y's. The sign with 4y is plus, so I have plus 4y. Then I have plus another 4y, and then I have minus 3y, right? So we can now go ahead to add or subtract the terms with the same variable, and also do likewise with the terms with the y variable. But in the form, in its original form, whereas we have x, y, x, x, y, y, we can't go ahead to add or subtract terms with different variables. So when you are asked to simplify an algebraic expression like this, the first thing you need to do is to collect like terms. And the like terms are terms that has the same variables, right? The same variable or group of variable. So, and then you bring all of them together. You can then go ahead to add or subtract. So we have 3x minus 2x. What does that mean? I have 1x, I have 2x, I have 3x, right? And then I want to take away 2x. I take away 2x. I have 1x left. Then plus 5x, that is 1x, 2x, 3x, 4x, 5x. Now, how many x do I have in total? I have 1, 2, 3, 4, 5, 6. So which means I have 6x, right? Now, plus 4y, it means I have 4y, 1y, 2y's, 3y's, 4y. Another plus 4y, another 1, 2, 3, 4. Then I'm to take away 3y, 1, 2, 3. Then I have how many left? 1, 2, 3, 4, 5. It is still my y, so I have plus 5y. And this is your answer, because at this point we now have variable x and y together. They are unlike terms, they cannot be added together. So this then be your final answer, which means we've been able to express this expression in the simplest form, where it can no longer be simplified again. So when you're asked to simplify, what you are asked to do is to express that expression in a form, in its most simplest form, where it can no longer be simplified. So we solve my examples. We have number 1, 5z plus 4x plus 7z plus z plus 6x. Number 2, 8y plus 5s minus 5y minus 3s plus 1. Number 3, 5f minus b plus 3y plus 2f plus 4b minus 2y, and number 4 minus x plus 2 plus 6x minus 3x. Now solution. Number 1, we have 5z plus 4x plus 7z plus z, and then plus 6x. Now, at the point where we have multiple variables, they are unlike, we can't solve them. Now, to go ahead to simplify this expression is to express this expression in the simplest form. And the first thing we need to do is to collect like terms. And what does that mean? It means that I bring all z's together, bring all x together, then I can go ahead to add the z's and go ahead and simplify the x too, right? So I have 5z, we have 7z with the sign is plus 7z. We have 1z with the sign, that's plus z. Then we come back for the x, we have plus 4x. We come back and then we have plus 6x, right? So we can now go ahead to simplify the z's, go ahead to simplify the x. Now, of course, when you see plus, it means you have it, right? So I have 5z, I have 5z's, 1, 2, 3, 4, 5, plus 7z, which means I have it, 1, 2, 3, 4, 5, 6, 7. Then plus 1z, which means I have it, 1z. So how many z's do I have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this gives me 13 z's, right? Then plus 4x, which means I have it, 1, 2, 3, 4. Plus 6x, 1, 2, 3, 4, 5, 6. So how many x do I have in total? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that gives me plus 10x. Now, at this point, I have z and x. Both of them are unlike terms. So I cannot add both of them together. So this then be my result, because I have been able to simplify it to the simplest form where I can no longer add or subtract both of them together because they are unlike terms. Now, number 2, we have 8y plus 5s minus 5y minus 3s plus 1. Now, for me to be able to simplify this expression, this is an expression with how many terms? 1 term, 2 term, 3, 4, and 5. So it means this algebraic expression has 5 terms. The first thing I need to do is to collect like terms. Collect like terms. So we have 8y. The next one is 5y, but the sign in front of it is minus, so we have minus 5y. Then we have plus 5s. The next s is minus, so we have minus 3s. You leave it with the sign. And then we have plus 1. This 1 is a constant, so it is not the same. It is not like with s. It's also not like with y. So we have it, we have plus 1. So what do? We can then go ahead and simplify the y's, go ahead and simplify the s, and then of course we have the constant on its own. So we have 8y minus 5y. Now 8y is what I have. So I have 1y, 2y, 3, 4, 5, 6, 7, 8. Minus is the debt I'm owing. So I have 8y and I'm owing 5y. So the wise thing to do is to pay my debt from what I have. So minus 5y means I'm going to pay 5 from the 8 I have. and I'll have how many y left? 1, 2, 3. It is what I have, so it is positive. So I have 3y, right? Now 5s, the sign with 5s is plus positive, which means I have it. So I have 5s, 1, 2, 3, 4, 5, minus 3s. Minus is I'm owing, which means I need to pay what I'm owing from what I have. So I'm paying 3, 1, 2, 3. I'll have 2 left. It's what I have, so it is positive 2s. And of course we have plus 1. It's a constant. This is our answer, because at this point we have variable y, variable s, constant 1. They are not like, so we cannot simplify them, we can't add them. They are all unlike terms, and then this will be our result. Part 3, we have 5f minus b plus 3y plus 2f plus 4b minus 2y. Now we can't simplify this expression because it contains unlike terms. So the first thing to do is to collect like terms. We have collect like terms, and then we have 5f, we have 2f, the sign in front of it is plus, so we have plus 2f, and of course b, the next one is b, and the sign beside it is what? Minus, so we have minus b, and 4b, the sign is plus, we have plus 4b, and then of course y, we have plus 3y and minus 2y. Now to simplify this, I have 5f positive, right? I have it, so I have 1, 2, 3, 4, 5. Then I also have 2, 1, 2. Total will be 1, 2, 3, 4, 5, 6, 7, and that gives me 7f. Now I have minus b plus 4b. Now minus b is 1 minus 1b, which means I'm owing 1b, but I have plus 4b. The wise thing to do is to take away my debt from what I have. So let me first count what I have, which is 4b. 1, 2, 3, 4. I'm owing 1, so I pay my debt. What would I have left? 1, 2, 3. I'm still the owner, which is plus 3b. Now I have 3y and I'm owing 2y. So I have 3y and I pay 2y's from the 3 and have 1 left. I'm still the owner of it, which is plus 1y. This will be our final answer, because you cannot add f, b, and y together. They are all unlike terms. Now, number 4, we have minus x plus 2 plus 6x minus 3x. To simplify this expression, the first thing we need to do is to collect like terms. So we say collect like terms. And then we have minus x, we have 6x, which is plus 6x, and then we have minus 3x, and of course plus 2. Now we have minus x, which means I'm owing 1x. I'm also owing 3x, but I have 6x. So if I count what I have, 1, 2, 3, 4, 5, 6. Minus 1x, I take away 1. Minus 3x, I take away 3. What do I have left? I have 2. But I'm the owner, right? Which means it is positive. So I have 2x. Remember, if I don't write the sign positive, it also means it's still the same. It is positive, especially when it is the first term. So then we have plus 2, right? Now, this is a variable and the constant. Both of them are not like. So you cannot go ahead to add or subtract. But then, in our next class, we'll look at how to factorize. We'll also be looking at factorizing of algebraic expression, whereby we bring out the common terms in an expression and then we factorize that expression. Till then, let's leave this as our answer. Please do these exercises and leave your answers in the comment section. If you encounter any difficulty, please do well to reach out to, and I'll be willing to respond to your difficulties. Thank you for joining the class. See you in the next class. Bye for now.